This video is about the creation and use of a self-correcting math worksheet in Excel but also in Google Sheets. The idea is that we can have a series of math problems. I've got addition, subtraction, a mixed version of addition and subtraction, multiplication and division as a series of worksheets here. So the children in a classroom would have an individual version of this sheet distributed to them by whichever network, Google Classroom or something like that, and they get a series of math problems. So for example, here I have 11 plus 4 equals, and I put these out in separate columns because I actually want to be able to make it relatively easy for me as a teacher to be able to change the values that are in here. At the moment I've got these locked, so I can't actually select them. I'm going to just unprotect this sheet here so I could go in, and obviously I could change each of these values. I could even leave these unlocked for the children to be able to change them if I want them to take ownership of the spreadsheets themselves. Now they are going to type in an answer in this answer column here. Let me type in a correct answer to begin with, and I've answered it as 15, 11 and 4. I've got a reaction which says great, and you can see up here I've got a formula. I'll explain that one in a moment. The other feature that's happened is down here I've shown that I've got one correct and I'm currently working at 100%. I started my test at 7:40. This is 7:40 in the morning, so I've got a started time. The next one here, 14 and 4, I'm going to get wrong and put in 15 again, and I've got my reaction, which is oops. Again, I'll come back and explain what's happening with that one, and I put a little X over in the column over here. That means that, I actually realize I've got it wrong. I've got some instant feedback, so I'm going to go back and change it to 18, and I've now got it right, so I've got 2 correct. I'm running at 100%, but I've still got my X marked over here to indicate that I didn't get it right the first time round. This one correct, and let's get this one wrong, and you can see when I press my enter that I've now got 3 out of 4, 75%. I've got 2 that are incorrect at the moment, or that were incorrect at the beginning, one of which is still incorrect. So the children can go through and complete this, and they can go back and fix up their mistakes, but you as a teacher are able to see what the first attempt was like in terms of its success rate. Now they can game this system a little bit, so they could actually discover that they can go back and figure out, well, if I delete my result there using the delete key rather than typing in a new one, then the X goes away. There's a time penalty that's going on with this. Ultimately what we're hoping is that they're going to get their answers correct. They are learning what the correct answer is. The indication over here just gives you a little bit of feedback perhaps. Now as we go through, so let me complete a few more of these, and then I'm just going to randomly get them all wrong. So we'll just get a few more of these done, and you can be setting these at whatever level of difficulty you think is appropriate for the children. Let me just get a whole lot of these wrong now. I'll just go through because I want to get it finished. And when I press the enter for the last one here, I have now got a finish time. So I've taken 2 minutes and 30 seconds. So it looks like 3 minutes there, but the actual seconds count is showing over here to complete my test. So I've run through. You can see that I've done a pretty poor job, and I've also obviously not been thinking about it. I've done it in only 2 minutes and 30 seconds of 40%. So I've got some instant feedback. I can go back and correct these. We do want them to be able to get them right. So if I go back and change these now and carry on, it's not showing the time is taking any longer, although I'm still getting them right. So the first attempt is being shown, but again, see, I'm correcting them and I'm showing up over here. Now, if I, in this case, think, okay, I don't want to have it showing that I made a mistake, so I delete this one, and then I go back and put in my correct answer, 28. You'll notice over here the time finished had disappeared. When I press enter again now, I've got it right, and I've got a new time finished, time taken, that is now updated to the fact that I've gone back in and I've been fiddling with it. So you do get a bit of feedback coming through. Now, there's another way of doing a problem like this. If some of the students know a little bit of programming, they might decide, well, okay, I'm going to use a formula to calculate what that is. So I know that if I press equals, and I can remember, if the cells are locked, they won't actually be able to click on a cell. But if I click on the cell here and go plus and here and then go enter, I'll get the value correct, but I've got a little note over the side here saying use your head, because I've gone and checked and seen that hey, they used a formula instead of adding it up in their head. Now, as I say, if the cell is protected, let me just delete that, and this will protect the sheet again so that I can't actually now click on the cell, so I can't click on it to get it in as the formula. I could, as a student, still know that I can type it in as B1 and then go plus D1 and get my answer correct. But again, I'm still detecting that they have used a formula to get the answer rather than having added it in their head. And so it's exactly the same procedure that's running through all the rest of these. So let's have a look and see how this is actually working. So obviously I've got to detect whether the answer is correct. In G here, let me unprotect. In G here, I've got an if statement. Now the first part of the if statement here is just to determine whether F1 is actually empty or not. So if it's empty, then we want to keep G1 as empty. So that's determining whether something's there, so I don't show a series of random or false information or zero information over here. The next part of the if statement is actually my calculation. So this part here is the calculation. It's saying, well, does the number that's in F1 equal the addition of these two numbers together? And so if whatever they've typed in there is equal to the actual formula that I've got, which is sitting over here, then it will say great. And if it's not, if that value is not true, if it's false, then it will say oops. You could of course have whatever you like in here in terms of your communication back, but one thing that I'd suggest is make sure you're consistent, because that has an influence further down in the spreadsheet, as I'll show you. So if I'm going to do that with once I've created my first formula there, I just copy that down obviously. But if I'm going to do that with a subtraction, you'll find when I come over here, protect that one, in the subtraction my formula has changed. It's now B1 minus D1. So you've got to make sure that your formula that you're using to detect is actually represented by the function that you are presenting to the students. In a similar way, if I come to multiplication, we see that I've got B1 times D1. So basically the same calculation is happening in terms of how it's presenting the information. We're just changing what it's looking for as a result that's coming out of F1. Now, I mentioned that it's a good idea to keep this great and oops as being consistent all the way through, because we want to calculate how many they're getting correct, and we're doing that down here. So this is using a countifs or countifs statement, and it's counting G1 to G20, and it's looking down here to find out how many times the word great appears. So it's counting up how many times there is great. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sitting in there at the moment. Let me click off here. Whoops, and just escape that, and I've got the 10 sitting down there. So if I put one more of these in and get it correct, it's now going to see that there are 11 greats, and that's giving us now the score for this column. We also have a percentage that is happening in here. Let's have a look at the percentage. So the percentage is checking to see if F21, this cell here, is 0 or not. If it's 0, it means that they haven't actually answered anything yet. This cell here is determining the percentage right so far. So we know they've got one great. They'll be getting a 1 in here. So we're going to see when they get the first one right, as long as this is equal to 0, then we're going to display percentage right so far. So when they get 1 right, then they're going to be, we're going to calculate F21, this number here, the number that they've got right, versus the number they've actually answered. So we're going to count up. We're doing a count A of this column to see how many they've actually attempted so far, and then we're going to divide that into the number they've actually got correct, and we're going to present that by formatting the cell as a percent. So that's going away and doing a percentage count of the number that they've got correct, the number of greats they received over there, and if they've got none correct so far, so over here they've got none right so far, it's presenting, so they've got 0% so far. It looks like it there, but if I get one of them right over here, well, now let's get one of them wrong first. So I've got a 4 there, so It's still not showing the percentage right so far because they haven't got any right. Let's jump to this one here, 19, and they've got 50%, so they've got 1 out of the 2 right so far. So that's the way that is making that calculation. The other features that we've got in here, well, in this one we are looking to see whether they have made a mistake. So this one's got an oops in it. So we're checking here, we're in H12, we're checking F12 to make sure there's actually an answer in there. So if F12 is not 0, it was not empty, then we're going to go away and do our actual calculation. And our calculation is looking to see at G12, is G12 equal to oops? If a G12 is equal to oops, then we're going to put an X value in here. And if it's not, then we're going to just remain with what we are, that is the H12. So we have a little loop, a little iterative calculation going on in here. This kind of closed loop is a special feature of Excel. It's now been added into Google Sheets, which we will have to turn on, and we have to turn it on also for our date. You'll see a similar function happening over here. So it's writing back to itself. It's saying, okay, if I've got a value in there, keep that same value, and otherwise it's returning with a nothing. So we get a nothing. If great is there, then it didn't trigger this if statement, so it's staying as is. Okay, let's have a look at the next one over here, which is formula. This is using a function called isFormula, which has been around for a while now. So if isFormula, what we're looking at is F1 using a formula, and if F1 is using a formula, then if that value is true, then we're going to enter this statement, use your head, and if it's not using a formula, then we're going to just show nothing. We could show something, but then we'd have an issue that all the rest of these down here, even though we haven't put anything in yet, would be showing up as a value. So it's better just to keep that exactly as a nothing entry. So we're using our head there because they had typed in a formula. We go back and type it in the correct way, and now it comes out. So if they did want to go back, they do the formula and then go back and overtype, there wouldn't be a way of detecting that. So your hackers will win out every time. Next, we're working with the time. So how long does it take for them to complete the test? First off, we need to know the start time. So we're using again an iterative function. We have a now statement in here, and we have our little loop that's going to be happening in here where we're going to be dropping a value back in. As I say, Excel and Google Sheets will allow this, but they'll complain about it the first time. It's something that you'll have to turn on. First off though, we need a target. So we're going to go away and check to see when any value in here is set to above 0. So if I do a count on this column and find myself not at 0 because somebody's put an answer in somewhere, so let's come into this one again, and if I start my answers, well, let's start over here at 29, is it? So it doesn't matter where I start, I want to trigger this value because I've now moved, I've put a value in here, so my count for this column has gone above 0. So as soon as I've got a value in there, that will let me get my count started. So my count is above 0. So once that's happened, I'm now going to my next if statement, which is checking. Now I'm in column A3. So if A3 is empty, then I'm going to do a now statement. So the now statement puts a time in, but if it's not empty, then I'm going to write back the value that is already there, A3, and if there's nothing happening at all, then I'm going to leave it as empty. Okay, so this is our little write back that's happening in here. Now in the same way, I need to detect when they have finished. Now they're going to have finished when my count, when all of these are full. So if I delete one of these, that count has now gone down to 19, so it's no longer full. When I type in a value again, it is full, so I see that my count will have gone up to 20. So I'm again using the same now function, writing the value back into A6. If it is empty, I can write it in. If it's not empty, then it just leaves the value that was already there in there. And the time taken is another fairly simple one to be able to show. The time taken is just looking at the value of A6 minus A3. So unfortunately I've gone and deleted all my changed my now statements because I was in there clicking on them, and so it's reset them to 0. So let's just go and get rid of everything, and we'll start the whole process again to all of those. So we're going to get a value in there. Here's my start time, get myself finished, and I've got 57 and I've taken 7 seconds. So if we have a look in here, so my times are still working. So it's just if you're playing around, if you're actually in there playing with the formula and then press enter, you reset it to 0. So just be careful with that one. That wouldn't usually be happening because we're not usually letting students into that area. We'll go back, put my 9 in there and drag it down. And again, you see I've finished, taken 3 seconds, so it's quite accurate in terms of the measuring. Now with your times, you're just going to want to format those times to a type. I'm using hours and minutes, and for the time taken I'm using the hours, minutes and seconds. So good idea to go and format the two time cells there. So format those cells to something that you find useful. So it could even be just minutes and seconds that you want to have instead of hours, minutes and seconds, up to you. So we did our counts down there, we did our percentage to see how many is correct, we've looked at getting some feedback directly on their answer, we've looked at getting a way of having an indication if they've gone back and changed after the first answer, which we'd actually really quite like to do, and we've looked at how to determine if they've cheated by using a formula. It's not really cheating, it's been very clever, but we're trying to practice our mental maths here. We've looked at getting an iteration going on for the time being started and the time stopping, and then we're just using a simple calculation to record the time. Now the only other thing that we really need to look at is how to turn iteration on. So we're going to go to the File menu and down to Options, and then in Options we go to Formulas, and here is the iterative calculation. So you've got to make sure that is turned on. If that's not turned on when you first try and use this worksheet, you'll get an error message and you'll be asked to go and turn it on. So once that's on, it should be able to go away and work. Now if you are working in Google Sheets, you have a similar sort of issue. So in this case I've got exactly the same sort of thing going on. So here is my same calculations you can see happening across the top, same percentage, count S, all of this is basically the same, and the same start time. Now recently they have changed Google Sheets so that you can now find the spreadsheet settings, and under calculation you now have iterative calculation. So we have to turn iterative calculation on. In both Google Sheets and in Excel you will find that these are turned off by default. So you'll need to turn them on, save it in your sheet. It could be that when you give somebody an Excel sheet for the first time, that iterative calculation, it does not stick with the sheet, that they have to turn it on the first time themselves. In Google Sheets, when you save it with the iterative calculation turned on, it should carry over with it, but can't guarantee that. So if you're getting an error message, you'll just have to make sure that they go in and have that feature turned on. Hopefully this is useful to you. You've had a chance to see the formulas. You can zoom in and have a look at those, and you can produce some nice interactive worksheets for students in your classes. I've been using this over a number of years, and I've gone back and just tidied it up, added in a few extra little features, and really the main part though is that they can see some numbers and get some instant feedback on the values that they think they are. All yours.